Let us prove the following trigonometric identity. sec⁴θ multiplied by 1 minus sin⁴θ minus 2 times tan²θ minus 1 equals 0. That is, the left-hand side equals the right-hand side. Let us start solving the left-hand side of the expression. It is sec⁴θ multiplied by 1 minus sin⁴θ minus 2 times tan²θ minus 1. Now use the identity for difference of squares, so we know that 1 minus sin⁴θ can be written as 1 minus sin²θ multiplied by 1 plus sin²θ. Replace that in the expression. Now rewrite the left-hand side as sec⁴θ multiplied by 1 minus sin² multiplied by 1 plus sin² minus 2 times tan² minus 1. Using the Pythagorean identity, we know that 1 minus sin² is equal to cos²θ. So we replace 1 minus sin² with cosine²θ. Now the expression becomes sec⁴θ multiplied by cos²θ multiplied by 1 plus sin² minus 2 times tan² minus 1. In next step, we divide sec⁴θ into two parts. So expression becomes sec² times sec² multiplied by cos² multiplied by 1 plus sin² minus 2 times tan² minus 1. Sec is equal to 1 over cos, so sec² becomes 1 over cos²θ. Now the expression becomes sec² times ni over cos² multiplied by cos² multiplied by 1 plus sin² minus 2 times tan² minus 1. Now simplify the fractions. Cos² in the numerator cancels with 2 powers of cos in the denominator. So we are left with cc² multiplied by 1 plus sin² minus 2 times tangent² minus 1. Now distribute cc² into the bracket. We get sec² plus sec² multiplied by sin² minus 2 times tan² minus 1. So sec² multiplied by sin² becomes sin² divided by cos². But we can also rewrite this as tan², so the term becomes sec² plus tan² minus 2 times tan² minus 1. Now use the identity. Sec² equals 1 plus tan². So we rewrite the entire expression as 1 plus tan² plus tan² minus 2 times tan² minus 1. Now simplify the expression. 1 plus tan² plus tan² gives us 1 plus 2 times tan². Then we subtract 2 times tan² and 1. That simplifies to 0, which is equal to the right-hand side of the expression. Hence, the given identity is proved. If you found this helpful, don't forget to like, comment, and subscribe to Robota for more trigonometry tricks and math explanations.